First of all, I would like to thank Spark Foundation for this opportunity, data analytics and virtual internship. As part of this internship, the first task is building the linear regression model for predicting student percentage for the given data. So I wrote the code for the linear regression model, and I have used the normal input method to accept the any user input method, any user input to find out the whatever the prediction score from the model which you have built. So I'll go through each step and I'll try to explain what is the code here. So I have note down the below steps here. First, I'll get the data from the Spark Foundation, that is a student data set, which is having two features and we need to predict one target column. I initially I done the data splitting, then I perform some little bit of exploited data analysis to identify which patterns it is showing, whether data is linearly separable or not. Then I built a linear regression model by using scikit library. Then I evaluated the some metrics like MSC, MAE, RMSC, and R2 score, so R2 score and R2 adjusted. So based upon that model, as in the assignment they have mentioned, we need to find out how much percentage we'll get based upon the hours student studied. So I I done that also. So I'll go through each step. So initially, I imported the Python libraries, which is useful for building this model. First one is Pandas, second one is NumPy. For visualization part, I use Matplotlib and Seaborn. So first thing is I have imported the dataset that is student scores by using Pandas, by using the read.csv because that's file is in the CSV format. Then I verified whether the data is coming or not actually. So that's the reason I use the df head. From there, I use the splitting the data. So splitting data is after sorry, before splitting the data, I need to check whether the data is how many rows or how many columns are there. So there are 25 rows and two columns. Two columns basically one feature and one target column. And we need to predict the one more output column, that is a scores and percentage, or we can call it as scores caret or scores hat. So I have split the data. Future is the outside. So that is X. Unpredicted value is scores. So they're assigned to Y. So by using the train test fit, I split the data into 80:20 ratio. That is X train and X test, Y test and Y train. With the random percentage for A2. That is whenever the model, whenever this code is run, it is going to predict the some sort of random variables. So random numbers to divide the data. So then I have performed some sort of EDA, which is very, very crucial for any sort of model, not only model for analysis purpose. So then I verified whether how many rows came for the train and how many rows went for the test. So X train test, Y train, or the data type of that. Obviously, it is numerical using regression. Then I found whatever the statistical modeling or statistical parameters which is showing. So describe. Then some basic stuff like finding the null values, duplicate values, and outliers, some sort of that. So there are no null values. I think 20 rows. It's like a very obvious thing. Then duplicated, I think we have one duplicate value. Then I removed the duplicate value in the X train and Y train. So there is no disturbance in later part. Then I verified okay whether the duplicate value is removed or not. Obviously, it is removed. Then I found out the outliers by using the same IQR method. IQR method, if you don't know what is the IQR method, interquartile range, which is like we have Q1 that is the first boundary and median is the middle one, and Q3 is the last boundary. So the data is within the range. There is Q1, Q3. There is good data. Otherwise, it is like outlier. So we need to remove that. So same thing I have done here. By using the NumPy library, I use the 25% of the data is Q1, that's quarter one, and 75% of the data is Q3. Then the difference is IQR interquartile range. And I'm finding lower bound and upper bound by using the minus 1.5 and plus 1.5 to the upper bound and lower bound to the minus 1.5. Then there's some basic outliers. So I found out whether there is any outlier. So obviously we don't have outliers here. And we can find out the same thing by using the box plot also. I have done this too. And I have given some sort of recommendation. So whenever the person read this notebook, obviously they easily understood. So then I draw the history plot because obviously it is numerical, right? So univariate analysis is simple. So that is I found out okay, how many hours the student is studying. So it is found that mostly student is studying 8 9 hours or mostly 3 to 4 hours. That is 3 to 3.2, 3 up to 4 hours. And I'm finding outliers. I think previously we have done using the IQR. Now we are doing with the box plot. There are no outliers. There is no need of removing outliers. Then I use the scikit-learn library to build the model directly. So before scikit-learn library for the for optimization, whatever the gradient descent library, gradient descent used for the finding the minimum global minima. So for the converging gradient descent, we need to pass the data in very correct manner. That is, data should be optimized. That is a normalized. So it will be very easy to converge gradient descent. So for gradient descent, we pass the x, that is a x values, input values, that is feature values. So that's the reason I use a normalization here. For normalization, I use a min-max function from the scikit-learn. So for x train, that is I use a fit transform. For test, I use a transform only. I think you know why I use that. Then this is the main part here. I use the linear regression from the scikit-learn linear model. Then I initialize the linear regression with the model, and I'm training the model with the hex test and y train, which is normalized data, and I'm finding the parameters, that is coefficients, and intercept, that is a y-axis point. So after performing this code, I found out coefficients are 78.59 and intercept is 13.41. So after getting this data, I used to draw the scatter plot whether our data is correctly subparabola, correctly uh, there or not. So I use the scatter plot. So which is first one is normal data, that is a input and output, that is a hours and scores. Then I after performing linear regression, I draw the regression line, which is like output value that is predicted values or how much apart from the given data. So this is linear regression line. Then after this, I evaluated okay how much percentage this model is giving results by using some auto square MSC MAE. I think there is very less data. Auto score is 96%. That's like it's giving good value, I would say. So whether it is giving good value or not, we need to predict. So if you identify here style, let's say 7. Okay, let's say for 7.8 hours, it is giving 86. Let's see how it is going to give or how much it's going to give. So if I run this, it is asking the input here. If I give 7.8, so it is giving 78.35. So it is almost near to the 86, I would say, more or less 5. If you give 2.7, let me check here. 2.7, it is given 28.87. So it is almost 1.3 something difference. So our model is working almost 96% is giving the results. Maybe we can pass the as many features as for this linear regression model because we are using scikit-learn library. If you are writing the code from the scratch or if you are using stats model library, it would be very different. Again, we need to remove the VAF scores and we need to remove the columns based upon the VAF. There are so much thing. But for simple thing, I use a scikit-learn library. And if you have any doubts, you can reach out to me on LinkedIn at Lokesh M. I'll share my all details in this description. Thank you.